All right, guys, moving on into 13.2. What we're going to start working on here is eventually getting towards something big and kind of scary looking at first called the unit circle. But before we do that, we're going to start off with the concept right here of graphing angles. So it's a new kind of graphing you guys haven't done before. It's not all that difficult to figure out. So we're not really going to bother with a whole bunch of vocabulary or theorems or anything like that. We're just going to dive in and do a problem. We're going to graph a 100-degree angle in the normal way that we graph things in what we call standard position. So if you remember from geometry, an angle is just what happens when you have two rays, one looking like this, and then another one that shares a common endpoint here, and the angle is formed in between them. Well, just like in geometry, that's what we're doing here. When we're graphing angles, we're going to draw two rays. And the first one here is always starting at the origin and then shooting out straight to the right. So that's the little note that I gave you guys right here. We're always going to start what I say or would consider the east position right here, always pointing straight out to the right, or 3 o'clock if you want to think about it as a clock. So always, we start in that position, and that's what we sometimes call the initial ray or the initial side of your angle right there. So guys, I'm going to say this a third time now. Every single time we do this, we always begin by drawing that first ray shooting straight out to the right. Then from there, we're going to draw a second ray that's 100 degrees away from this one that we drew initially. So the second thing to note right here is that when, that exclamation point got moved right there, we are always going to proceed counterclockwise. So starting from this initial side, we're always going to move up in this direction like that, with one exception, and I'll tell you that in a couple of minutes. Now, a little bit of vocab right here I wanted to go over with you guys. When we're talking about the quadrants, everybody, of the coordinate plane, the prefix quad means that we're breaking things up into four. So some of you guys have heard this before, but just in case you haven't, the four quadrants in the coordinate plane, because we start at the initial side and go counterclockwise, this quadrant right here is the first quadrant. All right, and as we keep moving counterclockwise, then in this direction over here, we've got the second quadrant, which is in the top left corner. We'll keep going counterclockwise now till we hit the third quadrant now in the lower left position, and then we'll keep going over here into the fourth quadrant, which is in the lower right position. So just an explanation of what the quadrants mean and where they're located. One of the questions we'll be asking as we go through here is, what quadrant does an angle end in? So there you go. And speaking of the word ending, this is an important phrase here now too, guys. The terminal side of an angle is where the angle ends. That's what the word terminal means. So we're looking to draw this second ray now 100 degrees away from the first one. Now, if you think for just a second about what those quadrants all mean, most of you guys remember from geometry that a complete circle is 360 degrees. That means that half of a circle is 180 and a quarter of a circle is 90. So if this initial position right over here, guys, is where we start, what we would consider to be 0 degrees, then 90 degrees from that, moving counterclockwise, would get you right up here where the y-axis points upward. And if you were to keep going another 90 degrees counterclockwise, over here on the left at the 9 o'clock position, or due west, would be 180 degrees. Keep going counterclockwise another 90, and 270 degrees would be located down here due south, or you could call that 6 o'clock on a clock. And if you kept going another 90 degrees, you'd get right back where you started. So 360 degrees is actually the same position here as 0 degrees. Those are called coterminal angles, and we'll get to that in a second. So when we go to draw a 100-degree angle, we can tell here, guys, from those red numbers that we drew, that 100 degrees is going to be in the second quadrant. It's bigger than 90 degrees, but it's less than 180. In fact, though, it's pretty close to 90. It's only about 10 degrees past that, so I'm just kind of guessing now, but I would say then that this 100-degree angle would end somewhere right about there. So the way this would actually work, guys, we would normally draw just this little kind of arc going here with an arrow looking like that, and we would say, okay, that is our 100-degree angle right there. So it's the two blue rays that were drawn that make up the angle. The initial side always points off to the right, and then the terminal side, let me draw an arrow right here, guys. The terminal side is kind of the second hand of the clock, if you want to look at it that way. The last thing I wanted to talk about here is what's called a reference angle. This will become more important later on in the chapter, but when you're talking about a reference angle, two important things to note right here. Okay, number one, your reference angle is always going to be located in between 0 and 90 degrees. 0 degrees and 90 degrees. That means it's always positive and it's always acute. That's important. And the second thing about a reference angle, guys, is it always is drawn to the x-axis, never to the y-axis. Okay? Always drawn to the x-axis. So what you would do then, guys, is basically say, okay, the terminal side of my angle was right here in the second quadrant, and the reference angle then is going to come down to the x-axis from where we are right there. And if I were to ask you guys, what is the measure of that reference angle? Well, remember how we got to 100 degrees. We went 90 degrees up to right here, and then another 10 degrees past that. So if this was a 10-degree angle, that leaves an 80-degree reference angle right there, and that is what we're dealing with for our reference angle for this particular angle of 100 degrees. So these two rules always need to be followed for a reference angle. It's always between 0 and 90, always drawn to the x-axis. A lot of people would tell me the reference angle here would be 10 degrees, but that would be drawn to the y-axis, not to the x-axis, and that's why that one is wrong. Okay, so that's a decent amount of vocab within that first problem. Okay, I said there was going to be no vocab and I lied, sorry. But let's go a little faster through the rest of these. Now let's draw a 250-degree angle. So we always, no exception to this, guys, begin by drawing your initial side as a ray pointing straight right to the east. And now let's think about where 250 degrees is going to take us. 250 degrees is more than 90, so I'll keep going, more than 180, so I'll keep going through the second quadrant. But at the bottom of the y-axis right here, 270 degrees would be too big. So I'm going to go here into the third quadrant, but not all the way, and my terminal side is probably going to look something like this. So there's your 250-degree angle there in red. Guys, that's what we've got. And you can tell me here, I think you can see, that this thing ended up in the third quadrant. That might be a question that you guys are asked a little bit later on. I think that's on your homework. And then let's talk about the reference angle. So the reference angle is, probably should have drawn these differently in the other order. It always goes to the x-axis, and it's always between 0 and 90. So the reference angle is going to be this guy right here. Okay, and how big was that angle? Well, remember, we were at 180 degrees right here. We now needed to go another 70 degrees to get to the 250 right there we were looking for. So your reference angle then would be 70 degrees for this one right here. Okay, guys, that's what a 250-degree angle looks like. Let's knock out two more here, okay? A 750-degree angle. Now this starts to get interesting. So, without even thinking, the initial side is always drawn straight out to the right. Got it? And let's think about how far we need to go. This one's interesting because it's a pretty big number. One complete circle is 360 degrees. But you guys notice I didn't just draw that as a circle. I kind of pushed it off to the right because I'm not done. A complete circle is 360. A second complete circle is 720. So I'm going to keep going now with a second complete circle right over here, and I'm still not done. So two circles is 720. We now need to go another 30 degrees past that. 30 degrees is a third of the way through the first quadrant, so that terminal side right here might look something like that. So that little curly pigtail in the middle right here, guys, shows you what angle this is. If we didn't have that there, let me move all that for a second right there. If we didn't have any of that, you can't really tell what's going on right here. That really looks just like a 30-degree angle, all right? But with those little pigtails drawn in the middle, you can see that it's two complete circles, so at least 720 degrees, and then just a little bit more. Okay, so what would be going on here? This angle ends up in the first quadrant, and then the reference angle right there, well, what do we say, guys? We did 360 to get us right there, 720 to get us right there, and another 30-degree angles for our reference angle right there. So first quadrant, 30-degree reference angle. That's a 750-degree angle. And the last one I got for you here, guys, negative 675 degrees. I want to take you back to what we wrote on the last slide right here. We began with this little tidbit right here. Always start here. And when a math teacher says always, they mean always. So even though this angle is negative, we're still going to start from the same position here, straight out to the right, due east. But I want you guys to notice I did not write the word always right here, and that was on purpose. We proceed counterclockwise in the normal case when your angle is positive. But like everything else in math, when your measurement is negative, you go in the opposite direction. So this time, because the angle is negative, that means that we are now, for the first time, going to go clockwise around our unit circle. So 675, let's see where we're at here, guys. That's a complete circle right there. So that's at negative 360 degrees. Now, negative 720 degrees would be 2 full circles, and we're not there just yet. But if I think about this for a second, 720 is a nice number because it's 2 complete circles. Let's subtract 675 from that. That leaves us with 45 degrees left over. What that tells me, guys, is that this angle is 45 degrees short of 2 complete circles. So this is 1 complete circle, and again, I'm going clockwise now. Here would be, let's see, another quarter, another half circle, another 3/4 of a circle. So where were we, guys? We were at negative 360 right here. If I keep going with another negative 90 each time, this would be a negative 450 degrees. Another negative 90 would get us to a negative 540 degrees. Another negative 90 would get us to negative 630 degrees. We would need to go, we can approach this from either way, another 45 degrees past negative 630 to get to negative 675, which also kind of bears out with the 45 degrees shy of the second complete circle that we thought we were. So our terminal side is going to go right down the middle right here, guys, of that first quadrant right there. So just like in the last example, I didn't plan this on purpose. This is once again a first quadrant angle, and the reference angle here is going to be 45 degrees. Remember what we said, everybody? A reference angle is always drawn to the x-axis. That's what I have both here and here, and the measure of a reference angle is always in between 0 and 90 degrees. So those two things happened in all of these, even though I switched colors on you guys. Sorry, 80-degree reference angle there, 70-degree reference angle right there. So guys, that's a quick nutshell, in a nutshell there, a quick synopsis of how to graph an angle in standard position. So you guys can practice that on your own. I want to talk about one more thing here very quickly, and then I'm going to turn this video off because then we're getting into the harder part, and I'll make a second video out of that. The second thing I want to talk about is this word coterminal angles. So terminal, we already talked about before, means ending, and co is 2 things that happen together. So coterminal angles are 2 angles that end in the same position. So let me show you what we mean by that, everybody. We're going to find 2 angles here, one positive and one negative, that are coterminal with 165. Now, I'm going to show you this the graphical way first, but then when I get done, I'll show you a much easier way than that. All right, guys, a 165-degree angle. We always draw the initial side straight out to the right, and 165 degrees is a little bit less than 180, 180 being a half circle. So I would say that 165 is probably going to get us to right about there, and I would say, okay, there's the terminal side of this 165-degree angle. And while we're at it, let's do the same things we've been doing. This is a second quadrant angle, and the reference angle is always drawn from the terminal side to the x-axis. And that angle right there, let's see, we got to 165. A whole half circle would be 180, so I would do 180 minus 165 and get 15 degrees now for our reference angle. Now, I haven't actually answered the question yet. All I've done is I've graphed this thing. It said find 2 angles, one positive and one negative, that are coterminal with 165 degrees, meaning when we graph these angles now, we want to end up in the exact same position. So if I thought about this again, I could have another angle that also starts in the same position right here, but now what I'm going to do is I'm going to shoot past that 165 and keep going another complete circle until I land on that same terminal side, but the second time around. And what I want everybody to notice is that what we did, in fact, let me undo that and do this one more time. Follow the red this time. We went 165 degrees. Then we kept going another complete circle and ended at the exact same spot. So actually, I guess this is the fast way that I'm going to do this. Our coterminal angle came by going 165 degrees and then adding another 360 at the end of that. So all I've got to do is add these two angles up right here and get a 5 and a 2 and a 5. 525 degrees is a coterminal angle with 165. And what's the reason there? Because they're 360 degrees apart, and that's a complete circle. So this is the way you'll normally do a problem like this. You'll take whatever angle they gave you to start with, add 360, and whatever you get, there's one of your answers. But I also asked for a negative coterminal angle. So what I would do this time now is take 165 degrees and subtract 360 from that. Now this one is going to end up getting us a negative number here, guys. I believe a negative 195, if I'm not mistaken right there. And that is going to be our negative coterminal angle right there. That would have come by starting from standard position right here off to the right and then going backwards clockwise, going negative 90, negative 180, and then another 15 degrees right there, and there would be the negative 195. Now, guys, these are not the only coterminal angles. You could keep going now by taking 525 and adding 360 to that, and that would get you 885 degrees. That's yet another coterminal angle, and you could just keep adding 360. Or we could take negative 195 and subtract 360 from that, and that would get us negative 555 degrees, and there's yet another negative coterminal angle. So there isn't just one right answer to this problem. There's actually an infinite number, but it probably makes the most sense, guys, to come up with the smallest positive coterminal angle, and then I guess this is actually the greatest negative coterminal angle. But there are other answers that exist out there as well. I would just expect most of you guys to come up with those. Okay, that seems like a good spot to wrap up this short little video. We'll come back and finish this up. What we're going to do next in section 13.2 is a little bit more complicated than that, but this is a good place to quit for now. Good luck, everybody.